This conference will now be recorded.
Right. See, guys, when do we go for a single index and compound index generally? When we keep a predicate, when we keep predicate as a, as a one field, predicate means condition. If you are going with one conditional, read, then go for the single field index. When you are going for the multiple values as a condition, then go for the compound index. That's how the compound index and single field indexes are going to be used and created. Basically, you need to know the read patterns basically. So let me talk about it very quickly. Right. So we were talking about single field index and compound index. Anyway, I was sent this file already, right? What combinations index will be used, what combination index won't be used, that we have seen. But when do we use single field index? When we have a condition of one field. Like I was talking about only S number, then S number and S name, S number, S name, S address. If you are going more conditional statements, like more conditions you're giving in the query to find the data more uniquely and efficiently, then go for the compound indexes. Why? Because if you don't have compound index, it is going for the key lookups. If you have seen that, if you don't cover the all conditional fields and the index part, it will go for the key index, key lookups, though you have index on the first field. So in order to avoid that, in order to get the efficient plan, you had to create the index on the predicates or conditional. What is the condition you are going to give it basically? So on which we were working actually, db dot what was that collection? Like we were student, right? Was it student? Data what I entered, not this one.
It was lab.
Lab. Okay, okay, good. Thank you. Thanks for the lab. All right. I mean, this is the data we were working on, right? So like whenever you have a data like this and you wanted to find this first field was having the index, and when I'm clubbing the second field in the condition, it was going with the key lookups. Key lookups means whatever else is matching with that condition, everything is examined, but it is giving you the requested documents at the end. Key lookups are also keys examined. Key lookups me here means keys examined. More keys and more load, more performance issue. So try to create a single index which serve the purpose of multiple conditional statements. That is what the compound index means. Even in the under the SQL Server or Oracle Server or Postgres, whatever the product you pick it up, the indexing model is almost similar. Condition, what your condition, on what fields you are joining. If you are joining in the RDBMS, those fields must have the index. If not, it will go for the index scan. Index scan means what? Collection scan means what? It is scanning the entire collection. Scan means does not do anything. It just get all of your data and sort in memory for you. If it is going for the index seek or here index scan, what it does, it is exactly going to the record location, pulling it out, where you get the real benefit or exact system, you get the efficient computing. It just goes and fetch you the record what you wanted from the disk. It's not flooding the disk, it's not flooding the CPU power, it's not flooding the memory. So which means you are not like flooding the system. Basically you're indirectly saving the system resources by using the proper indexes. So indexes you need to call in such a way that should serve the multiple purposes. This is what I was clearly discussed, combinations. That is the reason I created one index on 3 fields, and it is satisfying this condition, this condition, this condition, and see, with this condition is also satisfied with key lookups anyway. So you need to compromise on few combinations anyway. So only 3 conditions are not satisfying. So we need to ask the people to follow these patterns to read the data. This is wherever we have a yes, We have to tell them that if they don't know, use these patterns so the index will get used and you get the good executions basically. If they are not using the, if we have this index and they're going with this or this, then again things are gone. They need to know first. The developer need to know what format they have to call the data to pull the data more efficient. It comes with experience anyway with the developers also. But anyway, we will trace the queries. I'm going to talk about that. If query is not following the standard, we can make them standard. If someone complains, we'll start doing our job. How do we do? I'll explain because I do most of the things in my environment. I do escalate, I handle escalations. So I'll trace the load. I'll ask them why these guys are doing this kind of. Then we'll eventually introduce the indexes will resolve this most of the time. Index plays very bigger role anyway. Right, single field index, index and embedded field also we've seen on a single field, and compound index we have seen, and index prefixes means this is a prefixes like what you can use, like order. The order matters, in which order you're calling the index. You created a compound index, good enough, but which order you're calling. So you have the index item available sold quantity, so the order matters basically. Order means you have to either way you have to keep the index, as if the starting of the value of the index if is included in the predicate or condition, it use the index. First value must be there. If first value is skipped and the any field you keep it, it won't use the index. If it is skipped, it must be combined. If you see wherever yes is there, first field is there, first field of the index. If you see here, these are all three yes means because it is there. And if you see this is yes, because the first field is there. This is yes, because the first field is here. So wherever you see no, the first field is not there. So the same thing in SQL Server also, when you create included indexes, the combination of indexes, you when you call it, you have to use the order, or else you have to include the first field of that index, else index won't be used. They need to know all of that. If they don't know the rules, then they don't get the benefit of the index. Next, sort operation. So as I said in the beginning, you guys remember indexing, when though data physically is jumbled, when you create the index, it sorts the data logically. It's not physically. Logically, it is keeping the, like it is keeping the references in the order. One is here, next to two is here, three is here. It knows. It keeps the references one, two, three, four, five, and something like that. It's a logical, references. These are all logical, but data physically is jumbled. Now come to the, if you understand this word, you understand this slide. In MongoDB, sort operations can obtain the sort order by retrieving the document based on the ordering in an index. See, if you are sorting the data and you don't have index on that sort field. See, let me do this. Example, I wanted to sort by name. How do I do that? db.lab, come on, find. I wanted to read all. Sort by field, we are giving the field name anyway. The field name is sname, right? Sname 1. Either you read the data ascending order or descending order. One means ascending order. So you see letters are, did I give sname? Sname only. A, L, B, oh, it's not sorted. Okay. Actually, this is uppercase, lowercase. Uppercase, lowercase, when you have it won't sort properly. That's a big problem. Another big problem, right? Oh, sorry, it should be -1, not L. If you see the higher to lower, but if you the uppercase, when you keep the uppercase combination, there you see the sort will behave differently basically. See, this B should be after A basically, but not in the order. The rest of the letters are in the order if you look at. Same thing here also. Anyway, in the reverse order it is fine, but L, see, L should have been here at the up. This is not in the order. Why? Because it's an uppercase. So it will handle either uppercase or lowercase. Basically, you have to follow one format. When you are giving the name, first letter should be uppercase or lowercase. case insensitive. Mongo is a case insensitive that you have to be very careful on that part. Anyway, I'm sorting the data. If I'm sorting the data, if it has to be more efficient, you need to have the index and that field. Okay. If you don't have index, what happens basically? What does this will do? See, let me read this. db dot. If you answer this, you got the most of the indexes then. db dot lab get indexes. Now we have an index on the s number, s name, s address. Now I'm sorting on the s name. Does it use the index? What do you think? Does it use the index? It's a question.
Yes.
Let's see. It's a sort operation, and if you see sort key generator, it won't actually. Why? Because it's not in the order. Your it's only for the select read sort key generator. What it is saying? Stage sort and total document examine. Total documents. Okay, you're reading everything anyway in that. So sort anyway it works. But the thing is, it won't use the index because you have the index on the first field, right? Collection scan. This is what exactly I was explaining. If you see in the sort, if I use a sort, if first field must be included. Anything index, index order prefix is very important. If I use these together, yes, it goes with the collection index scan instead of the collection scan. It went with the collection scan. It's not good, which means it did not use the index at all. Because you need to use the order of the index. You broke this order. Okay, you broke the order, good enough. Either you keep s name and s number in the reverse order, which is fine. You need to include the first field. If not, it will not use the index. We have seen that combination, right? S address, just s name also does not use the index. I did not given that. Oh, just if you pass only s name in the condition, that also does not use the index basically. Why? When you broke the order, you need to include the first field, as simple as it is. If you keep the order means starts with the first field only. When you break the order, you break the order here and you keep the first name. He did not keep the first name, it is not using an index. You broke the order, but you included the first name, then it is using the index. So index works in that direction only. So you need to understand the work. That is what I was talking about. You need to understand what patterns they are using when they are reading it. Based on that, we introduce the indexes basically. And we need to tell them also this index is there in this fields. Use these field patterns by looking at the existing indexes to get the best benefit of the index. So if I wanted example, if I wanted to sort the data by number, oh, come on. See, if I sort the data, see, this is not in the order, right? It is not in the order, actual physical data. db dot lab dot find. If I sort the data, sort by s number. I'm going to keep s number. If I give this, it will go with the index scan instead of a collection scan. It is sorted the data. Now let's see the execution. Indexing plays very bigger role. That is why we are spending a lot of time here anyway. Okay. If you see, it is going with the index scan because the first field, or you included the first field of the order of the index prefix you followed, it went with index scan. It is the most efficient plan basically. Now, if let's come back to here, see guys, sort operation that use the index often have better performance than that do not use the index. Obviously, why? Because if you don't have index, it has to load all the data in the memory and sort in the order. If you have an index, it is already sorted with the index logically. It is in the data is sorted logically with the index, though it is physically jumbled. Logically, data in sorted with the index 1, 2, 3, 4, 5. It is keeping the references in the order. That is what one or minus one is saying to the index. When you're creating, sort the data in the ascending order or descending order. It knows the order already. Then when you sort the data, it will just call the data from the disk. It does not come into the memory and then sort the data. So there is no double operation, single operation, basically, that you need to catch. If the query planner cannot obtain the sort order from the index, it will sort the results in memory. This is what I was saying. If you have the index and index is already ascend, definitely index must be either ascending or descending. There is no option for you. So what order you are calling, it knows logically, it will fetch the data directly in that order and give it to you. It does not, sort again in the memory. It does not do the double operation. Single operation is enough. And reading the without the index, sorting the data without the index is very dangerous. Why? Because if example you have 1 billion records and you're trying to sort, what happens? It will pull out 1 billion records, does not know the sorting because it does not have the index. That is why MongoDB, they have restricted it. Sort operation. If you sort a field, if you are sorting the data on a particular field, it does not have the index, and your sort operation is exceeding 32 MB, it will fail automatically. It does not execute. That's a good thing they did it. Sort operation that do not use index will abort when they use more than 32 MB memory. Why? If you allow them, they will eat all your memory, all will other operations will wait or they'll fail because of the single query is taking all the memory. See, when you have index, it just fetch the data what the order it is there with the index and give it to you. Does not do the work in the memory. It does not occupy the memory. Basically, it will flood the IO if you are doing the bad sort without any conditional, which is fine, but you're leaving the memory and CPU to the system, just other operations can continue at that moment. So the thing is, the MongoDB did a good job anyway. They are not allowing you to do the sort operation if your sort is exceeding 32 MB and you don't have index on the sorted field. What you are using, that is the field you are using here. Sorted field means here this is number. It has index. It will progress. If not, if it is exceeding 32 MB, the operation failed. Allowed memory for the sort operation exceeded. Please use the indexes kind of error. It will throw. It will give you good information. So that is something you need to know. Certain multiple fields. If you wanted to do this, let's do it. So let's see what it is using first. Index can because the order is used. The execution starts. Data is sorted on the S number, sorted on the S name, basically. The uppercase makes a very big thing. It won't go in the order, but other things will go in the order. That's how it is. You can sort on multiple fields if you want. Memory. This is another important thing in the Mongo, especially. Only for the Mongo, not for the other products. Only for the Mongo. What Mongo does in terms of memory, this is a good discussion, especially for the memory. I'll call this again in the memory management. We have a performance tuning further. So now, all see example you have. There are two things in the Mongo. You have example. There is a formula. The formula also will explain how the Mongo will take the memory, on which basis it will take the memory. We have that formula. I'm going to talk about that under memory management. For now, just have an idea. It's an idea only. Clear cut, like you have this 120 GB memory. How much will be given to what? How much will be given to what? There is a formula for that. Use a formula internally. The formula I'll discuss when we pick up the memory management, not now. But anyway, now if example you have 120 GB, assume a case, okay, 50% of the memory by default, 50 mostly 50% minus one something, 59 GB it uses for the internal caching. Internal caching, what internal caching does, all indexes whatever you create, it load into the memory. All whatever you create on the machine, all indexes will sit in the memory. Why they are sitting in the memory? If I'm going trying to read something, index values are in the memory. If I have the index values in the memory, directly I can fetch data from disk. I no need to go to the, to find the index from the disk and again point to the actual physical location. You have the indexes in the memory. MongoDB try to keep all of your indexes in the memory if possible. Based on the RAM availability, if you keep more RAM, more indexes will sit in the memory. More index sitting in the memory, more performance you will get it. Why? Because index is readily available to the query in the memory itself. It knows the locations of the data. It will fetch the data immediately. There's two caches we have: system internal cache and file system cache. The rest of the memory will be used for the data fetching. Roughly 50% of the memory will be used for the indexing cache only in the MongoDB. Other memory part will be used for the data retrievals, data sorting, data, whatever you do the product, something kind of, it will use. It is not absolutely 120 till 50 GB to use it. As the indexes you are keeping, example, it has to take 59 GB assume a case for indexing. You have only created 4 GB of indexing assume a case. It will occupy only 4 GB. It is dynamic. As more and more index are adding, more and more space required for the index, more and more memory it will occupy up to this capacity. If it is not, it won't occupy by default. MongoDB dynamic in terms of memory, consumption, it is dynamic. So we will talk about it, how MongoDB actually handle the memory, because that is very, very important component for the MongoDB. RAM is very, very important because it is processing lots of data. When it is processing the data, it need a memory. Through memory only data will process basically at any point of time. How it deals with the data in the that comes in the memory management. For now, keep in mind that all of the Mongo indexes it will try to keep in the memory itself. That is what. So for the fast processing, ensure that indexes fit entirely in RAM so that system can avoid reading from the indexes from the disk. Basically, if you have good RAM, more indexes will fit into the RAM. If you have a very huge database or very huge data on the single system or replica set maybe, or sharding, though each shard got a huge data, you need to have sufficient RAM. At least, you are fitting that indexes on each collection in the memory so that all read operations can actually refer the indexes from the memory itself. It does not go to the disk. If it is going to the disk and read into memory again and pick up the pointer and go to the data location, pulling it out is lengthy operation, double operation. If you already have the index in the memory, it directly fetches the data. So that's how it is. MongoDB designed for that. To check the size of the index on a collection, if you really wanted to check on one collection, you can check this. Anyway, this will be given in many ways. db.lab stats. This also will give you the actual storage occupied by the indexes. If you see total index size, it is in KBs, it is in bytes. It is 53 KB it is occupied for the index. Total 2 indexes. Number of indexes, n indexes means number of indexes are 2, and total space occupied for indexes are 53 KB, and ID is picking up 32 KB, and this index is taking 16 KB. It is giving the index wise sizes also. If you see one index and in that index is taking a lot of space, you have to think of that index again. Is it really required or not? If it is really benefiting, keep it back. If not, delete it. Some indexes will take huge storage, like text index. I'm going to talk about that. Text indexes will take quite a long space, quite extra space. We'll see that. I mean, index also sometimes badly hit the memory because the index size is more. And you need to identify the index size like this. It is giving the each index size of the collection here. And if you wanted to find the total index size, this small function is there. Anyway, this is going to fit this value only, total index. db dot class, what was it, lab, right? Lab dot, I'll use this only, total index size. Okay, see, you're getting this value. It is shortcut. It's just getting the total indexes on the collection. You have a lot of indexes. You can get this value from the collection.stats. That is what I have used. db.lab.collection. This thing I'm going to explain. No need to worry. What is this stats? We have a discussion further. For now, we are talking about the index. We are focusing on the index right now. So db.lab.stats, if you give it, it is giving you the entire indexes details and each index sizes as well, number of indexes and total size of the index. When you're reading this, you don't want all of this, only you just wanted the total index size. That is what it is reading, db.lab.total index size. This is exactly it is reading and giving you that value. And that is what the slide is mentioned. To check the size of your indexes, use this function in total index size. Is it clear? If you use multiple collections, you must consider the size of all index in all collections. If you have lots of collections, lots of indexes, what is the size together? Like index by collection, you have to collect and check what is the memory consumption is going on based on that basically. It won't tell you that it is occupied for the index. This is the amount of space. Anyway, we have some queries. We'll talk about it when we talk about the memory management. Where are we? Right, multi-key index. Let's talk about this. Multi-key index db dot. We have one multi-key works on only array fields. Right, this is exactly. So multi-key index means it's a array field. This array field. This is a field. These are the values, right? If I create index on this one, it will add the index everywhere and all of these fields. That's all of elements of the array. This is an array field. These are elements basically. If I read example, let me do it. The same thing we are reading about, right? So let's see what it is doing. Is it going with the collection scan or index scan? Collection scan, which means it doesn't have the index on the even. Let's read this way. You have to keep colors. Maybe I'm just reading on field blue example. If I'm trying to read that also going with the collection, this conditional statement, which means that this field does not have the index. The the conditional field does not have the index. So if I create the index db dot or else or else, oh, it is equality conditional, right? Yeah. Hmm. So or else what I'll do, maybe because I need to talk about something else also. Phones addresses. How do I give you best example on this one to make you understand? Let's go with this data only. We have the phone address, phone number is given. Can I convert this into array? I have to do all. Okay. What and all we can keep db.lab. Let's insert the new records else. Difference collection scan, index scan. Just a minute, there is a question. Difference collection scan, index scan. There is collection scan means it is reading the entire collection. Index scan means it is scanning the index and getting the data. Index scan is always recommended. Collection scan always not recommended. Collection scan means it is scanned entire collection and getting you the data. Index scan means it is using the index and fetch the data, and it is scanning the index and getting you the data. So always index scan is. There are only two things we have in Mongo, unlike SQL or any other RDBMS. Collection scan or index scan. If you talk about RDBMS, we have table scan, collection scan, right? We have table scan, we have index scan, we have, and seeks. Table level seek, index level seek. There are different levels. That is a different story. They are then we cannot compare that here. You have only two things. Collection scan is scanning the entire collection. Index scan, it is scanning the index and getting data. So index scan is always is required for us. Okay. Okay. Anyway, I'll pick up this multi-key index with that colors. That's enough. It is simple anyway. You definitely understand. Right? Right. This is what we have. Whatever the field you read, you try to read. It is not using the index, even conditional. So what I'll do, I'll go and create the index on that one. db dot colors, not create index. Where I need to create the index? On the index, the array field colors. 1 in r minus 1. It is created. Index got created. Number of indexes before, after, and okay. Okay one means executed always. Now the same plan. If I'm trying to read now, it will go with the index scan. Previously, the plan it was giving was collection scan. After the index creation, it went with the index scan. So if I'm trying to find any other fee other element of the, so it no need to be in the order. Anything you read, anything you try to read out of that, it will use the index by default. You create the array field. If you create the index and array field, it will apply entire fields of that elements of that array. That's a good thing. That is called multi-key index. You are creating the index on one field, but it is created on all values of this array. It's like that. For example, instead of blue, I'll go with the yellow something. Yellow is not in the beginning, right? Anywhere it is, it use the index. That's a good thing of the multi-key index. If I use this, it is going with the index scan. So what you need to understand, let me come to I'll conclude it, don't worry. To index field that holds an array value, then only multi-key will apply. Multi-key does not apply to the single field. Like you don't have array field, it does not apply. It applies only on the index, sorry, on the array fields. To index field that holds the array value, MongoDB creates an index key for each element in the array. Each element, if you create the index on the array field, it will apply the index on all elements of the array. That's something good. These multi-key index supports efficient queries against array field. Why? Because anything that you keep as an element as a search condition, it will use the index. That's the benefit of it. You don't need to go and create the index on every field of the array. It's not required. Multi-key indexes can be constructed over arrays that holds both scalar values, string numbers, and nested whatever it is, whatever you have it. You are text, you are having the text, you are having the number, you are having whatever you have inside that, array. This is a text. Still, it is working absolutely fine. You keep the numbers like phone numbers array. Phones equal two numbers you have. You defined it as an array. You create the index on the array field. It will create the index in both the elements of that. It could be a number. It could be text. Whatever it is, numeric and strings both. MongoDB automatically create the multi-key index if indexed field is an array. You do not need explicitly specify the multi-key type. You know what you mentioned, just create the index as usual. It applies the index in all fields of the array. That's it. You don't need to create each element on each element, the positional, all that. We read, right? Slicing, positional of index reading. We have seen that in the code. We cannot create single index and two array fields. This is another big thing. Let me do it quickly. It's not too big. I wanted to do this update. How do we do update? Because let's go with the multiple. Anyway, let's do it. Colors. Wherever the color is red, set extra field. What I wanted to keep, just phones, whatever it is, just I'm keeping an example. Extra phones. And let's read it how it looked like. It got added here at one location only. Colors right. Okay, first element. I did not go with the multi-true. Anyway, which is fine then. That is something good for me. Then I'll include a few more records. so that you understand. So what is that? While next white. When it is update, it will update only first matching record. If you want it to update all, multi-true. I'm making two fields as an array. I'll read the data just a minute. I'm adding that extra to every field actually. Now let's read this data. Come on. Right, this is how the data got added. Anyway, it got added. Now, what I'm going to do, I wanted to create the index on this field and this field. Both are in, array fields. Both are array fields. If you're trying to do, what is array field? This is array field. Colors in array field. To the single field, you are assigning the multiple elements. It goes in the square bracket always. Array assignments goes in the square bracket. See, this is square bracket. If you, when we are reading the other data, this is not array. This is not array field. This is not array field. This is not array field. Just a one assignment. Whenever you have more elements for a single field, more elements means you have more elements, right? Red, yellow, blue for a single field. This is an array field. Got it? Question is, yeah, what is array field? Array field is something, it has a more elements assignment, basically. Now I want, you have the index on this one, but you wanted to create one more index combining these two. So, but you cannot do that. So db dot colors create index. This is a real admin job. It is admin job. You need to know all of this. Colors one and phone one. So, and two index fields combining together, we are creating one index. It will throw the cannot index parallel arrays, but you cannot introduce one single index and two array fields. That is what the statement also. We cannot create a single index and two array fields. It did not allow you. But if you wanted to create index, create on this separately, create on index separately. That's that way it is, but not together as a single index. Normal fields you can do it, but array fields you cannot do it. Is it clear or not? Say something, I'll move to the next index. Is it clear?
So Ravi, what is array index? Sorry, array. What is array? Can you just give an example of array? Here in our
Array means a array can have a more values, more than one value as an assignment. You see, colors has an assignment of red, yellow, blue, and phone. You see, primary number, secondary number, both are there in a single field. Multi values, multi elements, we are assigned to single field. It's a single field holding the multiple values. It's an array. Not clear?
okay, before before in the address only we give US, but in the address if we give US and India, it will be a multiple.
Array,
So multiple
exactly.
field. Okay,
Yes,
okay,
that is a
okay.
multi-value assignment. Multi-value assignment for a single field. That is called an array. But you are mentioning address, like India and separately address address one, India address two separately. That is not array field. But address US dot US comma India, then that is address field become an array.
Yeah, got it. More than one value in the same field is called array. Yeah.
Exactly. That is exactly the word you can say. Right. This is clear to everyone. Index on the array field. How does it work? Create the array on a single field. It will create the index on the entire elements of that array. You don't need to go and create each element. It's not required. Again, you cannot create the single index on two array fields at a time. That is another condition. TTL index, I don't need to talk about this much because we talked about already. You guys remember? I was talking about the capital index and TTL index. You guys remember or you forgot? I created already did this. You want me to do it again? Say something. If you want to do, I'll quickly do it. If not, I'll move on. I'll skip this. I'll just read and skip this. Do you want me to do again? Say something. Say something nice. Just overview. Okay. See guys.
Let's go with it.
Okay, let's go with it. Fine. So see, TTL index only works on the date field. Does not work on the other fields. Date must be there. Then only TTL index must be applied. Without date, it does not do anything at all. It does not make sense if you're trying to do. Let's create. What are the collections we have? Okay, I'll create one new collection. db.emp insert. Okay, just few records. emp number maybe d was the date of joining. We are applying the current date to the date of joining. What was that function we had? Is it a new date? DOJ. Is it not a new date? What did you say? Date is not defined. What? How come? This what? Does it pick up just the date? That's not. I'll check this out. Or we can use it kind of. Right, new date. It is calling up. What the heck it is saying then? This is correct. New. Just a minute.
D capital letter to what?
New date. What was it?
D capital letter or what that is?
Oh, right. Ah, good catch. Very good catch. I was wrong on that one. db dot. Here D must be capital. Very good catch. How could I miss that? Okay, that's a good catch. I'm just going with few records just to make you understand quickly, so that if you see it, I can move on quickly out of it. Right? db dot emp dot find data is like this. Whenever you have a date field and you wanted to expire the data, if you don't have a date field, you wanted to expire the data, then capped collection we already talked about. That is no more discussion. This indexing is we have, that is why I'm discussing again. You have to look at that video and pick it up. So there is a date field and you wanted to expire this data after how many minutes, how many days, how many, you had to know that there is a data which is you don't want after some time, just flush it out using the TTL index. db dot emp dot create index. You have to create the index on doj, okay, 1 comma, you have to mention this mandatorily, you have to mention expire after seconds. How many seconds it has to expire? After 30 seconds. Quickly. Why? Because we don't want to give too much time. It'll take too much time to expire. Now index got created. So this data will be wiped out after 30 seconds. It takes 30 seconds. It will go through the date function, it will read it. Okay, wait for 30 seconds. So it is gone. Why it is gone? This data age is over 30 seconds, it is flushed away. If you keep reinsert the same data, we got the data, same data back again. This is the last one anyway. You got the 4 records. How many record doesn't matter. It matters only the age of the record. If the age of the record becomes 30 seconds, over 30 seconds, it will flush the data. That is called TTL index. For some data, for some reason, you don't need it after some time, then TTL index is the best way of cleaning up the data automatically. This functionality we don't have in the RDB mesh. You don't have automatic flush. This is there in the Mongo. This is something good feature, right? So this is a lately inserted record, the latest one, 51 second. And till this time it is qualified, it is gone. Now this will be gone in next schedule, next 30 seconds again. Like this, data will be wipe out.
So
Right?
is it a like configuration, DB configuration, or it is DBM instance level
No,
configuration?
it's not instance level, DB level. It's index. It's an index. We are creating an index on the field, on the date field. It's not instance level. It
Oh,
is not
okay,
DB level.
index. Okay,
Just the
it's object
index.
kind of. Okay, got index. Yeah,
We created
got
index,
it.
right? Where here we created index on the date, date of joining, and expire after. You mentioned how long, after how many seconds data has to expire. If it is 1 day, 36,000 seconds, right? 1 day equivalent to 36,000 seconds. Keep it 1 day data, it will keep, and the other day it will automatically wipe it off.
So this we can create at any point of time, like maybe like say after 2 years, if my
No, you
data
can,
is increasing. Yeah. Okay,
at any point of time you introduce it, will just wipe out all the data which is older than the value what you given automatically. In
got it.
real time, maybe it is application logs, maybe application logs, audit logs, or like anything like your web clicks, whatever it is, you're generating the data, and that the data does not make sense after some days, does not make sense at all. You don't want application logs. Maybe you always look at the latest logs to find what is the error at that moment. You don't need 10 days before logs to verify or troubleshoot. You just wanted the latest logs all the time. Keep 1 day logs or 2 day logs maximum. The older logs just expire it, so that you are keeping the data at minimal, so it is not occupying the system resources unnecessarily, like CPU and everything. When you have more space, more maintenance in terms of in the backend also. So that will be avoided. On the unnecessary data, why you are wasting your system resources? That's why this concept came. TTL index are special single field indexes that MongoDB can use automatically remove the documents from the collection after certain amount of time. Just now we have seen. It is useful for certain types of data such as machine generated event log. Machine generated means, see, event logs. We have Mongo. There is a tool called Splunk. Splunk will connect to all our servers and get the server logs into the Mongo. The Splunk is a tool, guys. ETL kind of tool it is. Splunk. It is a tool which fetches all the logs from all the servers load into Mongo. And that data we don't need too longer. Maximum 2 days or 3 days. That's what troubleshooting is required, and the ongoing troubleshooting. It's not something 10 days ago what happened you don't look at. Right now what's going on? Why the system is not responding? Why is product is down? What is errors? The current one you wanted. So that data you have to expire. Logs, whatever the logs, like application logs, audit logs, all that. Session information that only need to persist in the database for a finite amount of time. Who are connecting, who are out of going down to the database, something information. Whatever it is, the basic word is you don't need some data. What some data is, application log, audit log, whatever it is. After some time, use the TTL index, as simple as. When you are creating, you mention the time, how long after it has to be expired. If the indexed field in a document is not a date or an array that holds the date value, document will not expire. You definitely have the date field in it. It's mandatory. And replicas a TTL background thread only deletes the document on the primary. This is another drawback we have. Like it does not delete the data on the secondaries. It only work on the primary. Secondary members replicate the deletion operations from the primary. Later on it will pick it up, but actually it is deleting on the primary. The same command, it is going through the op log and deleting the data from secondary. That we'll see architecture, you know it well. TTL index single field in or single field index. Compound indexes do not support. Only on single field it will work. You don't need compound. One date is enough. Why you supply 2 dates to expire? One is enough. So that way it will work on a single field. So this is called TTL index. Any questions? If not, I'll move to the next index. I'll try to finish the indexes today. The next are easy anyway. Unique index. Let's see this and then come back. So now, if you see, okay, we have this data. I'm trying to create a unique index. Can I create on this one? What is unique means? Unique means no duplicates, no reoccurring number. You should not use the same number again. Can I create the unique index on this one? Yes or no?
No.
No, you cannot because
No.
it has a unique. So I'm trying to create index. You can create actually if you want, but it will throw the error. Let's try. That's number one. And here you have to use the unique. We have a lot of things we can apply. We have the discussion. Don't worry. Unique true. That's it. If you run this command, it should create the unique index, but data has already duplicates. Error, duplicate key error, collection index, dup key until here it is duplicate. Here dup means. So it has a duplicate key, you cannot do it. Duplicate key. So like that. So just what I'll do. Why to enter all the data again? So let me see. We have the db.class. What we have? Class. Some data I wanted to play. Okay. Do we have here 1, 4, 5, 9, 10, 15 duplicate we have? No, I don't want to qualify.
Check in products.
Okay. It has only item. Anyway, it will work on this one. It is unique anyway. But I need just the number. Basically, you can apply on anything, basically. Anyway, item should be unique. Maybe that's good thing. That's good thing, right? db dot products. It works. Item should be always unique. You cannot duplicate the item again. Something good. So sorry. It must be 1 and unique true. Is created. Now, if I'm trying to insert new item with an existing item name, it will throw the error. Definitely, because you created it. It will make sure that it will not let you to do that. Insert. I'll copy paste one of the field. Bson, which is fine. Just I'm trying to do this. Insert. What does it do? It will try to insert, but it will throw the error. Why? Because item is already there. If I example the same thing, but I'll keep it mobile 1, will it accept? Yes or no? Yes, obviously it will accept. Why? Because this is it will treat, it should be exact match, as simple as it is. It should be exact match. If I go with the instead of that, let me ask this point again. It's a small m, will it accept?
Yes.
This is a tricky question again. So Mongo is case sensitive, it definitely accept. Mongo is a case sensitive, it's not a case insensitive, case sensitive. So it thinks that is uppercase is something different letter, this is something different letter. So different letter means different product. You have to be careful on that one especially. Okay. So unique means unique. That's it. It should not exact match number or letter, whatever it is. So we have seen that mobile was failing, right? If I do this thing, it will fail because it is already there. Just with the mobile uppercase, you already have it. And there is something called uh, compound also, compound unique key, mobile. That's anyway, my compound we don't go with generally, but anyway, let's come back to here. Unique index causes the MongoDB to reject all documents that contains the duplicate value for indexed field. If you are indexing it, if it is duplicate, you already have a numbers example. Number case absolutely good because with the letters, it will uppercase, lowercase, it will treat as a different. That is the issue is there. So apply the unique on the numbers. Numbers are good actually. Numbers are good. Why? Because if you entered one, you cannot enter one again. It will make sure that it will not let you to do. It will throw the error by default because the key is already there. You enter the other number. What I mean, it is item. It is a small m, big M. Both have it as taken. That is an issue. If you have a number, if you have a field with the number numeric, apply the unique field on the numbers. It is more efficient. Why? Because it does not let you to insert any number again, the same number again. So even the item field with the lowercase uppercase also cannot be possible because you have given a number to it on the number basically. If you use a unique constraint on compound index, then MongoDB will enforce the uniqueness on the combination rather than the individual. Okay, let's talk about this. Okay, let me show this data first. Products. It's simple anyway, you don't need to worry. So I'm creating the another index on the availability item and availability. Just simple, just you can catch it for sure. db dot products create index on multiple fields we are creating. Item 1 comma AQI, okay, 1. And those two together combination must be unique. Okay, unique. It got created. I need to delete the first index to make you understand, else you don't understand. So products, get indexes. This one I have to delete.
Here it's going to fail because we have multiple quantity AQI same.
But product is different. I'll talk about that. I'm going to come to that point. Not to worry. Does it go in the drop? So it goes in the. I don't think this required this. What it is saying? Come on. Oh, sorry guys. Drop index does not need this. Right. So we have a index on two fields basically. db dot. Let's come to your point, Viren. So if you see mobile and these together need to be unique, not one individually. Item MP3 availability 600 and fridge availability 300. So now I'll ask questions here, then you understand. db dot products dot find. Now I'm trying to insert the same record as it is. Will it accept? Will it accept or not?
No.
No. Okay. Come on, what did I do? I need to do the insert, not find. Right. The same record, I'll make it to 400. Will it accept? This is a question now. Think quickly.
Should.
It should. It should. Why? Why? Because it's not looking for the uniqueness on the single field. It is looking for the uniqueness on the two fields together. Item mobile exists, but on the if you see the availability quantity is different. So it will accept. It is verifying the two fields as a unique, a single unique. If you look at item mobile matching, but the availability is not matching. So these together, if you pick it up, they are unique. They are unique basically because both together it is validating, not one. That is what the statement is saying, that if you mention on multi compound index, it will validate the uniqueness on the compound fields, multiple fields, not on one. So it is picked up here. It is, you have this mobile again with the same letter, but the quantity is different, as it is treating as a different field, different document now. Is it clear or not? Confused? Clear? Not clear? Say something, please.
Yes.
It's clear, right? So if you see the same thing, if you use a unique constraint and compound index, then MongoDB will enforce the uniqueness on the combination of values. Combination. See your mobile availability quantity 300, mobile availability quantity 400. The combination, if you see together, they are different, not same. That is what. So MongoDB will enforce the uniqueness on the combination of values rather than the individual values for any or all values of the keys. It is taking the combination as a unique, not one. If the document does not have a values for the indexed field in Unix, it will need to supply the 0. At least if it is numbering, numeric, then you go with the 0, basically. Because of the unique constraint, MongoDB will only permit one document that lacks the indexed field. Uh, because of the unique constraint, MongoDB will only permit one document that lacks the indexed field. What exactly is saying? It's not, does not make much sense. You can combine the unique constraint with a sparse index to filter the null values for the unique index. Sparse index I never worked anyway. We'll talk about it. So now sparse index, it seems like it does not accept the 0 value, it seems. It does not accept the null value or something, maybe. So this we'll see. This point you need to keep in mind. If you created a unique index on multiple fields, it will validate the uniqueness on together, like on the fields what you have created, not on an individual basis. This is the best example already we have seen. Mobile availability quantity 300, mobile availability quantity 400. These two are not same, they are different as a combine. To take it individually, this is same, but we have index on two fields. Two fields together is a unique. Yes or no? Say something. Don't keep quiet, guys. Is it clear? Please say yes
Yes.
or no.
Yes. Yes.
Yeah, Ravi.
Thank you. See, if you don't say something, I feel like you have something, I'm moving on. That make me insecure. Like I wanted to make you understand. That is my motto. I don't want to just move on and complete the course. I just so everybody should understand. I'll give the time to everyone. Else I lose my satisfaction. MongoDB text indexes. Text indexes. I'll take some sample data just for the sake of discussion, guys. Not worry. These guys given any data? Generally, they'll give some data to play with. All right. This exactly I was looking for. Some text data, but to play with it. Right. We got a collection like this, db dot. I'll tell you, it's so simple, but very efficient in terms of when it is a text data, then only use this. This is the data we have. Now, if you see a description, maybe uh, I'll write something. I'll insert something. db dot stores insert Product is MongoDB. Just sake of this, ID is mentioned, so I'm going with ID6. And the product is name of the product, right? Name. Just I'll keep it MongoDB DBA. Description. Is description only, right? Description. MongoDB is good product. It has good openings. Something I'm writing. It is fulfilling lot of business. Just I'm writing. Just I'll tell you why I'm doing this. Use cases. Right. If you read this, data is like this. You can write any big statement. It is a description. You want to write whatever you wanted about the product. You have to, the description should tell the user that, okay, this is what it is. So you might mention in multiple lines and single lines, it will pick up. It doesn't matter how big it is. You're writing a feedback. You are writing about the feedback about the restaurant, writing about the, some shop, whatever it is. You're writing a feedback. Feedback will have a lot of, you write all your feelings about it, right? So it can be one liner, it can be 10 liner, it can be 100 liner also, depends on the user, what he's writing and how elaborately he's expressing his like consent, kind of whatever it is. So now if you're taking the feedbacks from the user from a website, it will come and sit in this like this. So how you make this kind of things, like a more efficient read, that something is very heavy to the system basically. So artificial intelligence works on the text indexes only, basically. What does it do? Artificial intelligence, it just pick up the words as a indexes. Let me show this. So now, first let me read this. db.stores.find. If you wanted to read, you have to go with the first create the index. Sorry, first create the index. I want to create the index, text index. Create index. You just mention the text description. Let's go with the description index. Description. What I'm text index, I guess. Does it go in the? No, in the. We just need to mention the text, right? So we created index, text index. It's not normal index. Text index is a different case basically altogether. If you see db.stores get indexes. Come on. Come on, I'll type it, guys. It's going get indexes, right? Text index. If you see text index, default language English, language override language. The good thing with the text index is case insensitive. This is a case insensitive. The letter wise, we'll see that. I'll show that. First, created index, right? Or I shouldn't have created it before. Okay, anyway. First, let me drop actually. I'll create the same index anyway. Because I wanted to show that it is going with the collection scan and then index scan. Both you need to realize it. Drop. I'm dropping the index for just to discuss something. So it must be in quotes. CLS db.stores.find. This is the data we have. db. I wanted to read some data. Then see the execution. Okay. And here, if I wanted to read, I have to go with the text. It is a text, right? Okay, without index you cannot read it. Text we cannot. Anyway, let's give it a try. I feel it won't accept, but anyway. Search what I am searching. I'll explain this syntax. I'm just checking it. Either you read entire thing, or if you wanted to read or search a field and read the data, you need a text index. It is mandatory to read. See, I'm reading something, I'm searching something, some word. If some word is there, then I need the feedback. So the restaurant people also, they need to see the like keywords. If the negative field like bad and not cooked well, something not bad, the kind of words they'll pick it up and then see it. Artificial intelligence work in that direction only with the words. But you have to create the text index to use to search for the text. There is no other option. Good enough. So we need to have index. Right, this is index. db.stores create index description. We are creating the index on this description field as a text index. It is done. So now the same thing, if I'm trying to read this thing, it will go to the each document. Does it go to each document? No, it does not go. Why? Because it will keep this value in the index value. If you go to here, it read two documents, 5 and 6. Wherever you have a good, see, goods also has a good in it. It just looked for this one. Even if I go with the uppercase, it is a case instance to that something is good. If I go with even capital G, still it fetch the two records. So how does this text indexing work? It will work on the words, not on the complete letter. It will work on the words. Words. MongoDB is a good. See, MongoDB is a something is a verb or noun or something like that. It's a grammatical. Mongo is example. Is not treated as a word. It won't give you anything as an output. Why? Because it's a grammar. It's a patching letter, like is, has, will, whatever it is, grammatical words, it does not keep as an index. Only on the words. Only on the words it will keep the index. If you need to understand, just follow me. MongoDB is not a grammar. Is a grammar. Good is not a grammar. It's telling about good or bad. Product is not a grammar. And is a grammar. Let's see. With and it won't pull out the record because it's a grammar. It is a grammar or it's something. Let's see what it is treating. It is also not treating. So opening is a word. Okay. And market is a word. Due is also, let's say due, what it is speaking as due. Oh, due is speaking as a word. So how does it work? Let me tell you this. Text indexes. Text indexes are heavier. Let's see this. db.stores. I'll tell you this. I just wanted to. If you see description 16 KB, we have less data, but text index will take a little extra space because it keep every word reference with it. Wait, I'll make you understand in and out on this. This is the data we have. When index work, the indexing actually work like this. This index what it does, first record. From the first record, it is a second record index and third record index. Yes, full text search, exactly the same. That's correct. So it is keeping the words in it. Okay, first index, what are the words it has? It has coffee and cakes, and it won't keep coffee and cakes. In the first index it will keep coffee and cake, and the next index what it is keeping, garment, hunger, something. Okay, hamburger. So both it is keeping, just coffee, both it will keep. But in this one, how many words it will keep? MongoDB it will keep, good it will keep, product it will keep, and good it will keep, openings it will keep, and morning market it will keep, due it will keep, and fulfilling and business. The rest of the things it won't keep. It is keeping the words in it, the references of the words. When you call the word, it look for that in the index reference. Okay, this word is in this index, no, in this index, no, and wherever is there, it is pulling the immediately that record. It is not going to the physical disk and reading the data. It is checking in the index itself that word is there or not. Following or not following? Say something, please. Text index, wherever you're keeping the index on the field, it will keep the words as a reference, not like, entire thing. Entire thing is not an index. The words in it is an index. MongoDB, if you try to, I was just showing that, like if you wanted to read, this is a format. Find the text index. You're calling the text index and searching what you wanted to search. So if I go with the has, there is has here is given, but it's not reading out because it's a grammar, it's not a word. So text indexes will applied on the like where you're asking the customer to enter their information or their disk, like feedback or their opinions about your company or their whatever you want it to. There is a keywords, the keywords it will look at and then give you the data. So artificial intelligence will look at each and every word. Index is something is keeping the words. It will look for the words, good, bad, like it'll see there will be bad. Bad means not good, bad and very bad. So something like that they'll write, right? Good means extreme good and really good and good taste good, something they'll look at that kind of keywords and trade it as at the end. And negative words, it will just look at it and read it. They'll give the combination for artificial intelligence. See, artificial intelligence goes with the texting format only. MongoDB will be used in many artificial intelligences by using the text indexes only. Text index, what it does, it will go and read the words based on the probabilities you give it. Good side you are giving these words, the bad side you are giving these words. It will look for those words in which indexes. It will pick up how many are occurrences. These many occurrences positive, these many occurrences negative. It will give overall rating to you automatically. You guys following? Not following? Say something. Just if I go with the coffee, how many records will come? Tell me. No. Just I wanted to ask this. How many records will come and how many records it will actually reads in the background? Let's see the execution plan also.
2.
Explain. Does it use the index or collection scan? Index scan or collection scan?
Index scan.
Obviously index scan. See? Why? Because we have the index. We have the index. We don't need to worry about it. Right. So it just goes and find, like wherever you have that kind of thing basically. So if you example, I'm just keeping this word, when you have lots of data, then it will make sense. But anyway, we don't have here. We are just understanding it. So come on, explain. I went with explain. All right. If I go with opening, there is something called only one record is there with opening, but still it went with the index scan. See, it is keeping the word as a reference, not the entire text as an index. Basically, it is not keeping everything in the index. It is keeping only the keywords, words, not the grammar again. Is and it has it. It will keep mostly, but as it won't keep it. It won't keep it. The it won't keep it. To it won't keep it. Is it won't keep it. Off it won't keep it. Like that. It is just keeping the keywords in it. Is it clear or not? Please say something. That's all about it. Nothing else.
Yes.
Text indexes, text index means it is keeping the words in the index field. When you're searching for that index, that word, it will go and find the index in the index reference itself. It is not going to the physical disk to fetch the data and sort it off. It has, the references are with the index itself. If index has that word, it will pull out that record. So it is just reading what you are trying to read. It is not scanning anything. That's how the MongoDB text indexes will work. And that's how it is searching the data as well. It's just going and searching just based on the words that you are using it. If it is clear, I'll close it off. MongoDB provides text indexes to support text search for string content in the document. of a collection, right? And text indexes can include any field whose value is string or an array or anything. Text is a versatile. It will pick up anything that you wanted. That word must exist. That's it. Go with the word based, string based at the end, basically. To perform queries that access the text indexes, use a text query. You must follow the syntax. There is no other way. If you wanted to read, text and search. This is the format you read the data. To index a field that contains a string, okay, or an array or string, include the field, specify the string that literal. If you wanted to example, if you have index an array field, you wanted to read first position of the array and you wanted to find that in the first position, then it will give you that. Maybe first name. You see array, first is like this. I meant to say, you are inserting a record. Just case, I'm just telling. Name, S number, whatever it is, just I'm mentioning one thing. S number, name, I'm keeping it array. I can keep it. First thing is actually the first name. Second thing is second name. That way I'm defining it. Maybe Ravinder, and second name is initial, like his last name B. So now this is an array. Right now it is an array. This is an array. I'm creating the index, text index on this one. So when I'm keeping the text index, I am going to read the first field of it. When I wanted to read the first field of it, name dot zero. Zero is going to pull out the first name and then search. That is what it is saying. First, you are picking the first position of the array and searching out of it. If I wanted to search this one, how do I search? Example. First, come on, right? So I'll go this way. First, you have to code the codes. Name dot zero. Okay, name dot zero, comma, this thing else I'll pass. It is reading the first position of this name array. First position, dot zero means first position. One means second position, like that. So you are reading the names as a condition, and it will go and read. That is what that sentence is saying, that if you have the array, you find out which element, first position element, second position. This is saying that basically we discussed during the array I was talking about slicing, reading the positional, all that. So this will read that way. So this is what it is talking about. Where this is basically first you are finding the position of the array and then reading out of it. First name of it. Wherever John is there, in the first name second you mention, and it is reading wherever John is available. It's like that. A collection can have at most one text index. Oh, really? You cannot create multiple text indexes? Really? Let's try to give. I'm not sure on that part. So I'm trying to create another text index in the name. So then you have to create the text index and multiple fields where you have this kind of thing. If it is allowing only one, that is the other option for you. Name, text, conflict, index options conflict. You cannot do it, it seems. You cannot. If you wanted to do, then what I have to do? If I wanted to overcome this, what I have to do? I have to create one index on both the fields, because this also have a text part. Coffee beans, kind of, right? Getting the point? See, if you have a two text fields, two description and then opinion, something polling or something, whatever it is, you are keeping multiple fields are running with a text and you wanted to search that kind of things, create the combined index and the text index and the combined fields. Let me finish this by to say, maybe you go blank and then I'll delete this index. Come on. Oh, now what I'll do, because two fields have the text, only one text index is allowed. Two, you need to behave smartly in that case. Why? Because multiple fields are running with a text field. In that case, you have to be smart. So stores create index. How do we create this text? This guy talked about that index.
We have only one field of text, right? You need to create
Okay,
two fields of text.
right, that's correct. At a time. At a time. It's one index. Okay, this way it will go then. Name is text and description also text. Okay. You have to mention a single index. Text. It will create one index. Okay. Now, oh come on. Text must be goes in the quotes. Right. Now it is created. Now, on two fields it is created the text index. Why? Because per collection only one text index is allowed. That is a limitation. For that reason, wherever you have this, we are taking advantage of that before. So now I'm trying to read. So if I'm trying to read, first let me read and ask you. What is the common thing we have? Java, discount clothing, clothes shop.
Coffee
Okay.
is common.
Coffee.
Right, coffee is common. You're correct. So I'm going with the coffee. So how many records will come out?
3.
3 actually. So this is has the coffee, and this has the
No,
coffee,
2.
and here
Sorry,
also
only
two
only
actually,
two,
two.
two actually, yeah.
If you do this, two are coming out, and if you go with the explain also, no, I'll ask one more thing. That will be the end of the story on this one. So it is an index scan, good enough, right? That is what we always intended. Store start find. Right. I'll ask one more thing. Last one. Instead of coffee, right. Mongo, Java. Where is Java else? Command. Clothes. Okay, this and this one, anything is common, you see only coffee. Okay, if I go with the burger, burger is in the first field. So in the first field also, it is looking for both the fields, basically. See, if you are keeping this, it just reading, oh, come on, so what happened? Double quotes, okay. So, come on. So what I wanted to say as a final thing is, even the text index is there on this field and this field. It is looking for the word what you're trying to read on both the fields, like this field and this field. If you see burger is only there here, here is the burger, not here, this side. So index you have on the name and description, both the side it is searching for that word, both the sides, not only in one thing. So Java here, and this side you have anywhere Java? No. Clothes? No. Shop? If any combination is there in this, then it will come out. Mango. Goods here, good is here, and anywhere. And this side, good is there anywhere? No. I'm looking for that combination, but it's not there. You need more data too for that. Anyway, you understood, right? Either I give this side or this side, it will get the record. Anything, because indexing is available on both the sides. In a single index is giving Java, hut, coffee, and cake. These 4 words it will keep first index, and second index will keep burger buns is another word, and government hamburgers. This will keep as a 4 words. Like that, it is keeping two fields values as a two fields text indexes of words into single index field. Following or not following?
Yes.
That's all about it. Sparse index I never used, guys. I never seen practically. Just it is there. Sparse indexes only contain index document that have indexed field, even when if the index field contains null value. Let me conclude this tomorrow. This I have never seen. This and this I never seen. Rest I have seen. Ast index I know. The rest I'll finish this tomorrow. No, I'll give a little idea about it. I never used these two indexes. Rest are all I have used. Geospatial index will be used only in Google Maps and anywhere you wanted to use a GPS system for finding the location distances. There, these indexes will be used basically. But I never seen this kind of things implemented in my environment. Sparse or AST index, I know we can create and we use it, but not these two. I never seen. Anyway, I'll give an idea tomorrow. Okay. So tomorrow we'll finish the indexing and we'll enter into the next module, any of that module. We'll see. Security or anything. We have a lot of modules to discuss about admins. Any questions about what I have discussed out of all? Any questions?